Good afternoon. Good afternoon. I'm going through the 2022 paper. That is your NSC Geo Paper 1 2022. I'm going to go through section B, which is part of the Mapwork. I'll also do atmosphere and weather. I'll also do geomorphology, but I'm starting off with the Mapwork now. Let's go through section B. So the thing that I always emphasize is when you are going through your map, guys, you have to make sure that you read the general information. It's very important. Let's go through it now. So Maryvale is a town in Mgugu, Ndlovu District Municipality in KwaZulu-Natal. It is 145 kilometers northwest of Durban and 5 kilometers southeast of Warwick. Maryvale experiences warm, wet summers and dry, wet seasons. The temperatures between winter and summer range from 5 degrees to 32 degrees Celsius. The topography within the surroundings of Maryvale varies in elevation from 1,018 meters to 2,308.8 meters above sea level. So this is the general information that we have about Maryvale. This is also the map that we have of Maryvale. This is the map that we are going to use. So let's go through the question. It is very important that before you start attempting answer any question in section B, you go through the general information. You can see from this map, we already know the province where Maryvale is located. We already know about the general climate of Maryvale, warm, wet summers and dry winter seasons. So this is what we know in as far as Maryvale is concerned. Let's go through our paper now. So the first question reads, start the information below. The orthophoto index map sheet west of, okay, start the map below. The orthophoto index map west of 2930 CA5, 2930 CA5. You are given 2930 CA5 here. So the question is asking you now, the orthophoto index map sheet west of. So where is your west? There is your north. There is your south. There is your west. There is your east. So what would be the correct answer then? The correct answer will be what? 2930 C4. This is to the west. This is to the west. 2930 C4. That's the west, which means your answer there is what? Is B. That's how you get your answer. Because here is west. This is east, this is north, this is to the south, this is to the northeast, this is to the northwest, this is to the southwest, this is to the southeast. So this is 2930 CA5. To the west is 2930 CA4. To the east is 2930 CB1. To the northeast is 2930 AD21. To the north is 2930 AC25. To the northwest is 2930 AC24. To the southwest is 2930 CA9. So this is how you do it. Your answer there is B. Let's move on to 3.1.2. The scale of 1:50, the scale of 1:50,000 shows a what is 1:50,000, which means already you are talking about your topographical map. Okay, we are talking about a topographical map, and you are aware that your topographical map is a small scale map. Okay, it's a small scale map, and also remember we said that the bigger the number, the smaller the scale. So your topographical map is a small scale map. Okay, so let's see from the options that we have in terms of area, which means what does it show? It shows a larger area. It shows a larger area. Okay, then small detail, larger area. Of course, a larger area, what do we have? It shows a larger area, which means here it shows with less details. Larger area with less detail. Remember, the bigger the number, the smaller the scale. Smaller scale is a larger area, but it's not detailed. So it's larger area, less detailed, which means your answer there is A. Your answer is A. The bigger the number, the smaller the scale. Smaller scale, larger area, less detailed. Okay? Small area, more detailed. Think about your topographic and your orthophoto map. In orthophoto is a large scale map. It is for a small area, but it's more detailed. Okay, so the answer is A. Refer to the orthophoto map. Calculate the straight line distance. Calculate the straight line distance in meters. Okay. So here you are given what you are supposed to do. You are calculating distance. You are calculating the distance. Okay, calculate the distance in meters. So you are calculating the distance in meters. That's what you are doing. Okay, let's see that the power line covers We are referring to the orthophoto map, which means this is the orthophoto map that we are going to use. The orthophoto map that we are going to use. This is the orthophoto that we are going to use. So we are calculating the distance along the power line from that covers in from 6 in block B3, which means from here, okay, to 7 in block C5. So we are calculating from here up until there. That's what we are doing. We are calculating the distance of the power line from 6 until 7. From 6 until 7. So let's see what we have in as far as distance is concerned. Let's see what we have. Let's see what we have. I'm just getting my ruler. Let's see what we have. Let's see what we have in terms of our distance. Okay. So if we are to measure now the distance between the two, all right. So from here, where it starts 6, up to where we have got our 7, you can see that we have got what? From here, all right, up until here, we have got 9 centimeters. We have got 9 centimeters. That's what we have. That's what we have, 9 centimeters. Okay, so we have got 9 centimeters. We have got 9 centimeters. So distance is equal to map distance multiplied by scale. The map that we are using is an orthophoto map. We are using a what? Orthophoto map. What is the scale of the orthophoto map? Is 1:10,000. Remember, our answer is supposed to be in meters. Our answer is supposed to be in meters. So we are going to convert this scale into meters, which means it becomes 1:2. How many centimeters are in a meter? It's 100. We divide this by 100. It becomes 100 meters. This is the distance on the ground. The distance on the map remains 1 centimeter. Okay, so we want to convert our answer into meters. We want to write our answer in meters, calculate the straight line distance in meters. The power line, we have already measured that. We have already measured that from here, okay, up to there. We have got 9 centimeters. So now that we have got this information, what are we going to do now? We are going to use our formula. D is equal to map distance multiplied by scale. What is our map distance that we have? Our map distance is equal to 9 centimeters. That's what we got. So which means we are going to say 9 centimeters multiplied by, what is our scale? We are using 100 meters. Multiplied by 100 meters. Then 9 by 100. 9 multiplied by 100. What do we have? We have got 900 meters. You can see them. So we have 900 meters. That is the answer. So that is the answer for this. The map distance between power line, that the power line covers from 6 in block B3 to 7, which is from here up to there. That is the distance in meters. Okay, let's move on. The next question reads, draw a free cross-section. We are now using a topographical map. Please refer to the topographical map. Draw a freehand cross-section from the recreation facility at F. The recreation facility at F. This is where your recreation facility is. Okay. In block D to G in block D3. So F to G, we are drawing a cross-section from here up to there. Okay. Indicate F and G on your cross-section. So the cross-section now, what we are doing, I want you to check, you can check the contour height. What is the contour height that we have? We have got F, we have got G. What do we have at G? You can see the height that is close there. We have got this streak beacon, which is 1,382. That is the height that is close to G, 1,382. So we have got something like 1,382 point what? Okay, meters. Okay, so on this that we have close to G, we are saying that is close. This is the height that we have. This is the beacon number. Let's check at our G. At our G, you can see it's at the bottom. If I try to trace it, you can see this is where our G is. Let me try to find the height that is closer then. Remember, here is 1,320. Okay, let me just try from here. Can you see it's closer to 1,100 if you can check. is closer to 1100. I'm getting it from here. I go with this, it goes close to where our F is. So I'm looking at something like 1100. I'm looking at something like 1100, or this 1067, the spot height. That is what is close to where we have got our F. So it means you are going to have something like this. F is here. Then we have got our G then. So your cross section is going to be more like this. This is where you've got your F. This is where you've got your G. How did I do that? Because you look at the height. This is a higher ground. This is a lower ground, which means from F to G, you go upwards, like the same way is here. This is a lower, okay, more like the foot of the mountain. This is at the top. So the cross section will be more like this. That's how you can do it. Cross section from here up to there. This is how you can do that. Okay, let's move on to the next one. Is the recreation facility at F in block D intervisible from G in block D3? So this is 3.1.5. Is it intervisible? Can you see G from F? So intervisibility now, you can be able to see G from FY because there's no obstruction. There's nothing that can actually block the view from F to G. So there is intervisibility. That's what we say. There is intervisibility, which means you can actually see FG from F because there's no obstruction. You can clearly see the vision from view from F to G is not obstructed in any way, so you can clearly see. So what is the next question? Calculate the magnetic declination of 2022. I'm going to use what I have on this paper. I'm not going to use the current year, 2025. I'm going to use this year, which is 2022. I'm going to stick to the condition of the question. Calculate the magnetic declination for 2022. The difference in years is 6 years, and the annual change is what? 9 minutes westward. So usually, if we are not given that information, we get it here on the map. Can you see? This is the mean annual change, which is 9 minutes westward. Okay, this is the magnetic declination that he has for this year, which is 2016. So we are calculating the magnetic declination for that year, which was the current year during that time. That was 2022. So we are calculating for what? For 2022. We are calculating for 2022. That was the current year during that time when this paper was set. So we are using we are calculating the magnetic declination for 2022. We have been given the difference in years, which is 6 years. Of course, I would assume that they have said 2022 minus the year that we have here. Can you see there's 2016 here? Minus 2016. All right. 2016, this is where the 6 years is coming from, the difference in years. The current year in 2022 was 2022 minus the year that is shown here is 2016. So the difference in years we have already been given, which is 2022 minus 2016. That's where 6 years is coming from, okay? But it's already given. Then what else do we have? The question is saying the difference in years is 6 years and the annual change is 9 minutes westward. So this is the mini annual change. So which means we are going to say what is our difference in years? It's 6 years. So we said 6 years multiplied by our mini annual change, which is also given here as 9 minutes westward. So we multiplied by 9 minutes westward. That is W, okay? 9 minutes westward. So if we say is equal to multiplied by, all right, our difference in years, which is 6, multiplied by 9. What do we get? We get 54 minutes westward. So which means we are going to get 54 minutes what? Westward. Okay, so we want to calculate now for 2022. 22 magnetic declination, which means we are going to take what we have on this map, which was for 2016. We take the magnetic declination for the year that is shown on the map, which is in this instance 2016. What we have got 24 degrees 42 minutes. So we get it as 24 degrees, what do we have? 42 minutes 42 minutes west of true north plus our, okay, total change that we have here, the annual total change we have by multiplying the difference in years, multiply the mean annual change, okay? So, which means we are going to add 54 minutes westward. So, we have got 24 degrees, 42 minutes. Let me just write it nicely. 24 degrees, 42 minutes west of true north, plus 54 minutes westward. So, this is what we are doing. This is our total annual change. This is our magnetic declination for the year that is shown here, that we have used to calculate the difference in years, which is 6 years. So now that we have got 24 degrees, if we add 42, let's just add them as minutes first. 42 minutes, this is the 42 minutes that we're adding plus 54, plus 54. What do we get? We get 96 minutes. So we have got 96 minutes, okay, west of true north. So our 1 degree is equivalent to 60 minutes. So we cannot write 96 minutes the way it is. We have to convert it to degrees. Okay, so which means we will have 24 degrees. How many degrees are in 94 minutes? We have got 1 degree. Okay, what are we saying? That because our degree is equivalent to 60 minutes. So we can say 96, okay, minus 60 minutes, which is equivalent to a degree. We are going to be left with about 36 minutes. So it means it's plus 1 degree plus 36 minutes west of true north. We have broken down this. We have broken down this 1 degree, which is 60 minutes, and this minutes that is remaining 36 minutes. So if we add the two, because we have converted our 96 minutes into degrees, which gives us 1 degree, 36 minutes. So it means our 1 degree is going to add to the 24. That will become what? 25 degrees. How many minutes are we left with? 36 minutes, then west of true north. So this is our magnetic declination for 2025, which is your 3 marks. This is calculate the magnetic declination for 2022. The difference in years is given 6 years. Then the annual change is given as 9 minutes westward. So what we have done here is we have multiplied this to get our total annual change. 6 years multiplied by our mean annual change, which is 9, we get 54 minutes westward. Then from there, for us to get the current magnetic declination for 22, which was the year, we go to our map. Then we get the magnetic declination for the year that is shown, which is 2016 here. And this is the magnetic declination for 2016, which is 24 degrees, 42 minutes west of true north. Then we add it to our total change. This is what we have done here. We add it to our total change. Then we got this, the degree 24, the minutes, they add each other, 42 by 54, we get 96. So we first write it as in minutes, which is 24 degrees, 96 minutes west of true north, but we do not leave it like this. Why? Because our 1 degree is equivalent to 60 minutes. We convert this 96 minutes to degrees, okay? Which means we are saying now from the 96, if we take out the 60 minutes, which is equivalent to a degree, we are left with 36 minutes. That's why now we have got this 24 degrees plus the 1 minute from the 96, 1 degree from the 96, that makes it 25. Then we are left with 36 minutes west of true north. So that will be your magnetic declination there. Then let's move on. Map interpretation 3.2. The wind that blows during the night at block C2. The wind that blows during the night at block C2 on the orthophoto. All right, let's go to the orthophoto now. That is your 3.2.1. Okay, what is this wind? 3.2.1 at C2. This is our C2. So what comes to your mind, guys? This is a valley. So valley during the night, we have got cold air that is sinking. That means it's katabatic. That is what? Katabatic. So it means it's C. That is katabatic. During the night in the valley, which means it's sinking. When it's sinking, it's called air that is sinking. Of course, that is your katabatic, okay? Refer to block D4 on the orthophoto map. Block D4. D4 on the orthophoto map. This is the block D4. As you can see here, block D4 on the orthophoto map. This is block D4. This is what you're referring to. What is the question saying? Which time of the day, morning or afternoon, was the photograph taken? That is 3.2.2. 3.2.2. You can see, okay, let's look at the shadows, okay? Okay, the shadows usually they fall on the southwest, so it is during the morning they fall into the southwesterly direction. So you can see this is block D4 we are talking about here. Look at your shadows here, they are falling to the southwest, which means it's during the morning. They are long and also they are falling into the southwest direction. We have got these shadows that are here. This is how you do it. It's during the morning. Why? Because the shadows on these trees, they are falling to the southwesterly direction. This shows that it is during the morning. Okay, we've done that. Then 3.2.3, they give a climatological reason for the large number of perennial water sources, dams, furrows in the topographic area. Okay, so here we are saying now, why do we have a lot of give a reason for the large number of perennial water dams? Okay, why do we have the perennial waters, which is usually used to store water? These are the perennial, the dams, of course, the reservoirs, your furrow. Why do we have a lot of these? It is because the rainfall is seasonal. So during the rain season, they store water. Okay, so that they can use that water during the dry season. So it means that the rainfall is seasonal. That's what it means. Rainfall is seasonal. Then refer to H in block B1 on the topographical map. H to block B1. This is H to block B1. H in block B1 on the topographical map. The question is saying, give river H in block B1 general flows in a northeasterly direction. Give a map evidence to support this. It's flowing in the northeasterly. It's flowing in a northeasterly. What evidence is there to support? That's what it's saying. H is flowing in a northeasterly direction. What evidence is there to support? Okay. The river flows towards the dam. The river flows towards the dam. Northeasterly, it's flowing towards the dam. You can see it's flowing towards the dam. That's number one. This is your dam, which means the dam wall is somewhere. The dam wall is somewhere here. So it's flowing towards the dam. That's one evidence. The V-shaped, of course, the V-shaped contour lines point in the southwesterly direction. The V-shaped contour lines, this one, okay, it points in a what? Southwesterly direction. Of course, that shows that your river is okay, is flowing towards this direction. The height increase in northern direction, you can see the height increase. Check here. Then you can check also what we have. There is a height increase. You can see one. Okay, that's what is happening. Okay. Then what is happening? Okay, the river flows towards the dam. I think that's the most probable one day. Okay, the B1 is reads, give evidence why the type of flow of the river flow is associated with the laminar flow. Why is it associated with the laminar flow? Obviously, we are saying that it is flat because the contour lines are further apart. It is flat, okay? It is flat because flat is gently sloping, widely spaced contours. That's another reason, okay? Then the drainage pattern, I circled in block E3, I circled in block 3. This is the drainage pattern in I3. And D3 on the topographical map is 3.2.5. What is the drainage pattern? Okay, that is more like your dendritic. You can see it resembles the branches of a tree. The tributaries are joining at acute angles. That is your dendritic. Then describe the underlying rock structure that is responsible for the drainage pattern. The dendritic, you know, guys, is uniform or homogeneous, resistant, horizontal layer. These are some of the general characteristics. Let's move on. Then GIS, refer to the photograph below that shows the environmental issue in block C2 on the topographical map. Block C2 on the topographical map. C2 on the topographical map. Okay, the environmental issue. Which symbol represents the environmental issue depicted in the photograph? Okay, C2. C2, what do we have in C2? This is the area. What do we have? 3.3.1. What do we have? That is your 3.3.1. What do we have? C2, what do we have? The environmental issue there. Okay, let's see what we have. I'm going to look at my diagram as well to have an idea. D is more like an excavation. If you look at it, it's more like an excavation. Okay, which means the answer is D. The answer is D then. Classify the photograph as either primary or the photograph is either primary or secondary data. Okay, that is primary because you are getting the information. That's first-hand information when you take a photograph. That makes it primary. First-hand information, you take a picture. Okay, that's first-hand, which is primary data. Give a reason for high resolution of the photograph, 3.3.3. The high number of pixels was used. You can talk about the pixels are smaller, the better quality camera, or the lens that are used. Those are the reasons. Then the last one. 3.4. How would the high resolution photograph assist a GIS specialist to find the solution to the environmental issue depicted? Okay, 3.3.4. The features are clearly visible. That's how it helps. The features are clearly visible. The features are clearly visible. Then refer to the sketch below of the infrastructure data layer in block C3 on the orthophoto map. Okay, in block C3 on the orthophoto map. So this is what we have on the orthophoto map here. Okay, so the infrastructure layer on the orthophoto map infrastructure, you are going to look at your roads, you are going to look at your power lines. Those are the things that you are going to include. Okay, C3, okay. So data layering, of course, road, this is a road that has already been put. So what are we going to add now? We are going to add the power line. We are going to add what? In block, what block it is? Okay, block C3 on the orthophoto, sorry. Block C3 on the orthophoto, C3 on the orthophoto. So the road has already been put here. So what we want is the power line now. Where's the power line? So which means we are going to have something like this. Okay, which is our power line. That's another layer, of course, that is our power line. This is the road, this is the power line. What else are we supposed to show? On the orthophoto, identify the missing infrastructure data layer, 3.3.6. Okay, I've done. Okay, identify the missing infrastructure data layer included, not included on the sketch above. Obviously, 3.3.6, that is your infrastructure layer. Infrastructure data layer, of course. Using the correct reference symbol, redraw the sketch and insert the infrastructure data layer as identified in 3.3.5. So we have now put, this is the road, this is your power line, part of the infrastructure, this is your power line that we have done then. Then what else do we have? We can also include the buildings in C3, the buildings that we are seeing, which means we can include the buildings. We can also include the buildings here. These are the buildings that we have. These are the buildings that we have. That's why I had to put the building here. I had to put also the building, okay, towards this point. I have put the building also towards that point. Then we also have the power line. We also have the power line there. So we also include the range with which the power line can cross the road. So it can be the range with which the power line can cross the road. So one mark is for the correct reference symbol, and the other one is for drawing the power line crossing the road, and the other mark is the positioning of the buildings. So we have got our buildings here, we have got our buildings there, we have got the power line crossing the road. This is here why we are showing the power line crossing the road. This is your road, this is your power line, this is your building, this is your building, power line crossing the road. So that's how you do. This is part of data layering. This is part of data layering. That's how you do it. Thank you so much. Please go through this. It will help you a lot. Please don't forget to subscribe to my channel. Do not forget also to share so that all other people have access to this information. Do not forget to share. Do not forget to like. Do not forget to subscribe to my YouTube channel. Thank you so much. Goodbye.